Good afternoon. Today's topic will be week 002, Coulomb's law, electric field intensity of your subject ECE 6201 Electromagnetics 1. I'm your OLC from Engineering Department from AMA Makati. Thank you. Good afternoon. Okay, today's course learning outcome will define the history and definition and introduction of a Coulomb's law. Then we'll also learn electric field intensity principle and discussion. Then we'll also learn the history of electricity. Okay, that is today course learning outcome. Okay, we start with the history of Coulomb's law or definition. Coulomb stated that the force between two very small objects separated in a vacuum or a free space by a distance which is large compared to their size is proportional to the charge on each and inversely proportional to the square of the distance between them. Where Q1 and Q2 are the positive or negative quantities of charge, R is the separation, and K is the proportionally constant. As you can see, these are the formula for Coulomb's law, wherein force equivalent to K times Q1 and Q2, then that is divided by R squared, where force and the charge is proportional to each other, and the force and the distance are inversely proportional. Okay? If the international system of units SI is used, Q, yung Q natin is magiging measurement niya or units will be coulombs or C. Kapag sa R naman, ang gagamitin natin is meter or M. Then kapag sa force naman, ang magiging SI unit niya is naka-newtons or N. This will be achieved if the constant proportionally K is written. Okay, kung ang equation natin is ganito, SI unit na mga ganito, sa Q is measured in coulombs, R in meters, and force are in Newton, the K should be this formula, 1 over 4 pi E sub O, where E sub O, ang value ng E sub O natin is nasa 8.85 times 10 to the negative 12 farad per meter. Okay? As I check, that is correct. 8.85 times 10 to negative 12 farad per meter. Okay? Then substitute lang natin dito is magkakameron tayo ng value na 1 over 4 pi. Then permittivity niya okay, substitute lang natin dito. That will be 1 over 4 pi. Then yung permittivity, that will be equal to 8.99 times 10 to the 9. Okay? Later, we have an example of that equation. Okay, let's continue. The Coulomb is an extremely large unit of charge for the smallest known quantity of charge is that electron, negative, and protons are positive. As we know, sa Coulomb is meron tayong unit charge nito. Ang smallest quantity ng charge is that electron, negative, or pwede rin naman siya maging proton or positive. Given an SI units as 1.602 times 10 to the negative 19 coulombs, hence a negative charge of 1 coulomb represent about 6 times 10 raised to 18 electrons. Okay, ang isang negative charge na 1 coulomb is also equal to 6 times 10 to raised to 18 electrons. Then, the Coulomb's law shows that the force between two charges of 1 coulomb each separated by 1 meter is 9 times 10 raised to 9 newtons or about 1 million tons. Then the electrons has a rest mass of 9.10 times 10 raised to negative 31 kilogram. Mga constant na value na rin yan. Yung electrons rest mass niya. Then, ang kanyang radius naman, ang radius nito is mangyari is order of magnitude of 3.8 times 10 to negative 15 meter. Okay, mga constant na value na yan. Okay. Continuation, the unit of E will be in force per unit charge. newtons per coulombs. Okay, ang E natin, o yung tinatawag nating electric field, is ang nagiging unit niya is, that is force per unit charge or newton per coulomb. Again, anticipating a new dimension quantity, that the volt having the level of joules per coulomb or newtons meter per coulomb, newtons times m over c. Okay, ito yung magkasama. We measure electric field intensity in the practical units of volts per meter. As you can see, sa electric field intensity, sa mga electromagnet or electromagnetism, since ang force natin is nagkikreate siya ng voltage, then after nun is magkakameron ng output na current kung ang principle natin is generator. Pero usually, ang formula or unit ng electric field intensity is in the practical units of volts per meter. Okay? Then this one is the field of sheet change. Another basic charge configuration is the infinite sheet of charge having a uniform density of PS. Yung PS natin, that is rho s coulombs per meter squared. Such a charge distribution may often be used to approximate that found on the conductor of a strip transmission line or parallel plate capacitor. Okay, as you can see, ang electromagnetism is connected din siya sa ating mga transmission line since meron sila ding current or nagkakameron din ng tinatawag nating charge distribution, ginagamit natin siya sa transmission line. For example, yung mga katulad ng mga coaxial cable, meron tayo din doon na conductors or another example of a transmission line that has a conductor of a strip, okay? Or a parallel plate capacitor, okay? That is the charge distribution. Also, static charge resides on a conductor surfaces and not in their interiors. Okay, since meron din mga static charge doon on the conductor surfaces and not in their interiors. For this reason, yung PS natin or yung rho s is commonly known as the surface charge density. Then the charge distribution family is now complete. Ito yung mga examples, yung point, line, surface, and volume. Yun yung mga characteristic ng charge distribution. Okay? Okay, for example, we have a problem in coulombs. Try to solve using your calculator. For example, number 1, the force between two identical charges separated by 1 centimeter is equal to 19 newtons. What is the magnitude of the two charges? Define the variables. Okay, meron tayong given na 19 newtons. Then meron din tayong dalawang charge, or Q1 will be the charge of the first body, hinahanap. Then Q2 will be the charge of the second body. Since hinahanap dito yung magnitude of the two charges, that will be equal. Then ang radius natin or distance between them or the separation between the two charges is 1 centimeter. Use the Coulomb law equation. Will be F equivalent to K times Q1 Q2 over R squared. Okay, we solve. With the use of this formula, we can equate the formula Q ang hinahanap. Okay, that will be Q1 times Q2 or same Q, that will be Q squared. Then cross multiply, that will be F times R squared. Okay, ito yun. Then ibababa natin yung K, cross multiply, that will be over K. Then since Q squared to, para makancel yun, is square root natin to, wala na yung square root. Wala na yung squared, then dito na magkakameron ng square root. Okay, now we will answer, that will be equals to square root of 90 times 0.01 meter. Yung 1 centimeter natin is kinonvert natin sa meter para magamit natin itong K constant na to. Yung K constant na to is ito yun. Yung 4, 1 over 4 pi, that will be 1 over 4 pi times natin dun sa constant na permittivity na 8.85 times 10 to the negative 12 farad meter. that will be equal to 8.98 times 10 to the 9 or 8.99 times 10 to the 9 newtons meter squared over centimeters over Coulomb squared. Okay, then solve na natin. Okay, 90 times 0.01, kinonvert na sa meter. Then naka-square yun. Ito. Okay, naka-square yan. Then over 8.99 times 10 to the 9. Okay, the answer is 1 times 10 to the negative 6 or 1 microcoulombs. Okay? Since there are two identical charges, dalawa yun, meron tayong positive and negative. 1 times 10 to the negative 6 coulombs or plus or minus 1 microcoulombs. Separated by 1 centimeter that produce a repulsive force of 90 newtons. Okay, that is for, these are the outcome already done. Okay, we start with the introduction and history of electricity. Okay, let's start. Records from at least 600 BC show evidence of the knowledge of static electricity. The Greeks were responsible for the term electricity. Okay, yung mga Greeks, sa kanila nagsimula yung term na tinatawag nating electricity. Okay, that is derived from their word for amber. Okay, and then spend many leisure hours rubbing a small piece of amber on their sleeves and observing how it will and then attract pieces of fluff and stuff. Okay, doon nagsimula yung electricity. However, their main interest lay in philosophy and logic, not in experimental science. Okay, doon nga lang since nirarab nila yung small piece of amber, is hindi siya experimental science kundi philosophy and logic lang siya. Then not in experimental science, and it was many centuries before the attracting effect was considered to be anything other than magic or life of force. Okay, next. Si Dr. Gilbert, physician to Her Majesty the Queen of England, was the first to do any true experimental work with this effect, and in 1600, and he stated that glass, sulfur, amber, and other materials which he named would not only draw to themselves straw and chop, but all metals would leaves, stone and earth, even water and oil. Okay, as you can see, dito nag-start din yung sa tinatawag nating electricity. Yung principle niya, usually is nag-start din siya sa mga metal, then experimental, kung ano yung magiging possible na magiging conductors materials. And include also the water and oil and earths. Okay, that is Dr. Gilbert was the first to do any true experimental work with this effect. The effect of life force. Shortly thereafter, an officer in the French Army engineer, si Colonel Charles Coulomb, okay, sa kanya pinangalan yung Coulomb's law natin ngayon, perform an elaborate series of experiments using a delicate torsion balance and invented by him to determine quantitatively the force exerted between two objects. Okay, according to this Colonel Charles Coulomb study, nag-perform siya ng maraming series of experiment using a delicate torsion balance, then invented by him, and also determine quantitatively the force exerted between two objects. Okay, siya naka-discover nun through experiment, the force exerted between two objects, each having a static charge of electricity. Okay, yan yung na-discover ni Colonel Charles Coulomb, the force exerted between two objects, each having a static charge of electricity. His published result bears a great similarity to Newton's gravitational law. Okay, kamukha rin nung na-publish na study ni Newton gravitational law. Okay, that is discovered about 100 years earlier. Okay, Coulomb stated that the force between two very small objects separated in a vacuum or free space by a distance which is large compared to their size is proportional to the charge on each and inversely proportional to the square of the distance. Okay, natakal na natin to kanina. Ito yung pinapakita yung formula na ito, force equivalent to K times Q1, Q2 over R squared, wherein yung force natin is proportional siya dun sa charge Q1 and Q2, and the force is inversely proportional to the distance. Okay, as I said before, ito na yan, proportional to the square of the distance between them. Okay, ito naman yung formula na kasunod, where Q1 and Q2 are the positive or negative quantities or charge. R is the separation, okay, ito yun, and K is proportional constant. In the international system, SI, pag Q is measured in the coulombs, ito, and R is in meter, then the force is in newtons, okay? The new constant, E sub O, is called the permittivity of free space. As I said before, yung E sub O natin, isang value niya is 8.85 times 10 to the negative 12. Okay, parehas lang din dito. Dito yung kinuha, 1 over 36 pi times 1 over 36 pi, then 10 raised to negative 9 farad per meter. Okay, that is the new constant E sub O. It's called permittivity of free space and has a magnitude measured in farads per meter. Okay. Next, the quantity O or 0 is not dimensionless. For Coulomb's law shows that it has a level of c squared n times meter squared. We will later define the farad and show that it has a dimensions of c squared over n times meter. We have anticipated this definition using this Coulomb's law. Okay, since nagkameron na tayo ng R dito, that will be Q1, Q2, yung K, ito rin yun, 4 pi E sub O. Then yung R is ito na yun. Okay, paano nagkameron ng R? That is, the Coulomb is extremely large unit of charge. For the smallest known quantity of charge is that the electron, negative or proton, is given 1.602 times 10 to the negative 19. Hence, a negative charge of 1 coulomb represents about 6 times 10 raised to 18 electrons. Okay, ito rin yung kanina. Naulit na lang din. Then yung electron, ang mass niya is 9.109 times 10 to negative 31 kilograms. Then ang radius naman niya, order magnitude, constant, that is 3.8 times 10 to negative 15 meter. Okay? But this does not mean that the electron is spherical in shape, but merely describe the size of the region in which a slowly moving electron has the greatest probability of being found and other known as charged particles. Okay, that is including the proton. Okay, all other known charged particles, including the proton, have a larger masses and larger radii and occupy a probabilistic volume larger than thus the electron. Okay, next. In order to write the vector form, we need the additional fact that furnished also by Colonel Coulomb. Okay, ito yung kay Coulomb's law stated that the force acts along the line joining the two charges. Ito yun. Meron tayong Q1 and Q2. Is repulsive if the charges are alike in sign or attractive if they are of the opposite sign. Okay, alam naman natin, mag-repulsive ang dalawang charges na alike in sign kapag magkaparehas, repulsive. Then attractive naman siya if there are opposite sign. Okay, that is on the charge. Let the vector R1 locate Q1. Okay, ito yung Q1 natin. Then we have here R1. Where areas R2, ito yun, locate Q2, yung charge 2 natin. Then the vector R12, okay, that will be this one, R12, is equal to R2 minus R1. Okay, para nakuha yon dito from this one. Ibig sabihin, yung R12 natin, yung magnitude niya o unit vectors ng R12 will be equal to R2 minus R1. Okay, these are the formula. R12 equivalent to R2 minus R1. Okay, from this figure. R12 equals to R2 minus R1 represents the directed line segment from Q1 to Q2. Kasi nga, nag-start na siya muna sa Q1 to Q2, kaya nangyari is R2 minus R1. Okay? Yun yung R12 natin. As shown in the figure 2.1, the vectors F2 is the force on Q2 and is shown for the case wherein Q1 and Q2 have the same sign, then the vectors form a Coulomb's law. Okay, iko-combine lang natin yung Coulomb's law with this one R12 or magnitude of R1 and 2. This will be first 2 equals to Q1, Q2, then 4 pi is sub O. Then meron tayong magnitude na R12. Then ito yung unit vectors naman na A12. Okay? Wherein A12 is a unit vector in the direction of R12. Okay? Then ang magiging equation ng A12 natin, ito, yung unit vectors that will be R12 na kanyang magnitude over dun sa absolute value na R12 equals also to R2 minus R1 over magnitude over yung kanyang absolute value na R2 minus R1. Okay? Next, now we will discuss electric field intensity. Electric field intensity, if we now consider one charge fixed in position, say Q1, and move a second charge slowly around, we note that there exists everywhere a force in this charge, second charge. In other words, this second charge is displaying the existence of a force field that is associated with charge Q1 and call this second charge a test charge QT. The force on it is given by Coulomb's law. Okay? Okay, ito yung first natin. First one equal to Q1, force T equals to Q1 QT over 4 pi E sub O R1, then R1 at saka R1T, that is squared, then A1 and T. Okay? Nabago lang siya kasi yung iba yung value ng magnitude. Writing the force as a force per unit charge gives the electric field intensity. Okay, ito naman ang formula ng electric field intensity natin. That is yung force over yung Q. Force T over Q1 equals to Q1 over 4 pi E sub O R1 of T, then I1 of T. Okay? Next, E1 is interpreted as the vector force arising from charge Q1 that acts on a unit positive test charge. More generally, we write the defining expression. Electric field equals to force over yung charge natin. In which E1, E is a vector function, is the electric field intensity evaluated at the test charge location that arises from all other charges in the vicinity. Okay, meaning the electric field arising from the test charge itself is not included in the E or the vector function of E. A unit of E would be in force per unit charge, or ang unit natin is Newton per coulombs. Again, anticipating a new dimensional quantity, the volt having the level of joules per coulombs, J over C, or newtons meter per coulomb, newtons times meter per coulomb. We measure electric field intensity, ito yung unit niya, that's volts per meter. Okay, madali lang naman tandaan. Pag sinabi natin ito yung mga dimensional quantity, kapag volt is the level of joules per coulomb. Pwede rin siyang joules per coulomb. Or kapag ano naman, naka-newtons, that is Newton meter per coulomb. Then, ang electric field intensity also, or E, pwede rin naman siyang maging unit niya is, or in practical units is, volts per meter. Ito usually ang unit ng electric field intensity. Okay? Now, we dispense with most of the subscript and reserving the right to use them again anytime there's possibility misunderstanding that the electric field of a single point charge become, okay, ito minsan nagiging equation, E equals to Q over 4 pi E sub O R squared times AR. Okay, yung R natin, ito yun. Yung vector R. Then, ito naman yung kanyang, since ito yung vector R, then we have the amplitude R. Okay, now we remember that R is the magnitude of the vector. Okay, this one, magnitude of the vector R. Then, directed line segment from the point at which the point charge Q is located to the point at which E is desired and AR is unit vectors in the R direction. Okay. We arbitrarily locate Q1 at the center of a spherical coordinate system. The unit vector AR then becomes the radial unit vector AR and R is R. Okay, ito na yung equation. Imbis na magnitude of vector R is ginawa na nating radial unit vectors. AR na dito. Then yung R is magiging R na siya na maliit. Okay, that is the formula. The field has a single radial component in its Beer's square law relationship is quite obvious. Okay, next. Okay, this will be the last topic for today's lecture. Okay, let's start. Field of a line. What is a field of a line charge? Up to this point, we have considered two types of charge distribution, the point charge and the charge distributed throughout a volume with a density PV or rho B equals to C coulombs per cubic meter. If we now consider a filament-like distribution of a volume charge density, such as a charge conductor of a very small radius, we find the convenient to treat the charge as a line charge density P or rho L coulombs per meter. We assume a straight line charge extending along the z-axis in a cylindrical coordinate system from negative infinite to infinite. As shown in the figure 2.6, we desire electric field intensity E, any at every point resulting from uniform line charge density. Okay, ito na yung ating equation or figure 2.6. The contribution DE equals to DEP AP plus DE say AC. Yung AC natin at saka AP, ito yung dun sa mga spherical form natin or cylindrical coordinate system. Okay? To the electric intensity produces an element charge of dq equals to PL dc located at distance say 1 from the origin. Then the linear charge density is uniform and extend along the entire z-axis. Okay, we have this one, rho L. Okay, ito yung kanyang amplitude or these are the z-axis. Then we have the R. Okay, makikita natin tatlong pa rin naman siya, coordinates, pero cylindrical form lang siya. Okay, that is 0, 0, then yung say yung pinakadulo. Okay, then we have is DE. Okay, from this direction, R equivalents to R minus R absolute. Okay, or R raise. Okay, next. Symmetry should always be considered first in order to determine two specific factors. Okay, may dalawa tayong specific factor na i-consider para sa mga symmetry or for this equation. First, with which coordinates the field does not vary. And the second is which component of the field are not present. The answer to this question that tell us which component are present and with which coordinated they do vary. Usually, ang coordinates naman natin dito is naka-cylindrical form. Okay, that is in a cylindrical form. Because we assume a straight line charge extending along the z-axis in a cylindrical coordinated system from negative infinite to positive infinite. We also desire electric field intensity at any and every point resulting from a uniform line charge density PM. Okay? Okay, alam na natin yung dalawang i-consider. Referring to figure 2.6, we realize that we move around the line charge varying P while keeping rho and say constant. The line charges appear the same from every angle. In other words, azimuthal symmetry is present and no field component may vary with the P.